Welcome to our next lesson as we are slowly deploying the DevHabit application. In this lesson, we're going to create our Postgres instance on Azure and see how we can approach applying our database migrations. For deploying our database to Azure, I'll be using the Azure service called Azure Database for Postgres Flexible Servers, and this is the more advanced Azure offering when it comes to deploying Postgres. It has better scalability, supports the latest Postgres versions, comes with a connection pooler, and it has many more advantages. So this is why I will be using this service. So we're going to create our database instance, configure the networking so that we can access this database from our local machine, and I want to do this to be able to apply my database migrations manually. I will also discuss a couple of other approaches you could take when it comes to applying database migrations. Now let's go into the Azure portal. We have to find the Azure Database for Postgres Flexible Servers service, and I have it available right here because I used it recently. So let me jump into this service, and I want to go ahead and create a new instance. We have a bit more things to configure here, so I'll take it step by step. First, I'm going to choose my DevHabit resource group because this is where I'll be placing all of the services for the DevHabit application. Then I need to give my server a name. Let's call it the DevHabit DB, and I'm going to choose West Europe as the location for my Postgres instance. When it comes to choosing which Postgres version you want to deploy, version 16 is the latest stable one on Azure, but I also have version 17, which is currently in preview, and this is what we were using in our local development. So I'm going to choose version 17, even though it's in preview, but just be mindful of this if you are really deploying this to production. Now, when it comes to the workload type, this is going to have a direct effect on our pricing. Now, if I scroll down, you can see that the current plan is going to cost about $600 per month, which is quite a bit of money. So I'm going to choose a development workload type, and you also have an option to configure the server that you want to use. So if I click this, I get to choose the compute and storage for my database server. For the cluster options, I'm going to leave server. When it comes to the compute tier, the most cost-effective one is going to be a burstable tier, but if this was really a production application, you would probably want to use the general purpose tier. I'm going to leave burstable, and I will choose the smallest instance size. When it comes to storage, I'm going to leave premium SSD. I'll choose the smallest storage size, which is 32 gigabytes. This is much more than I'll ever need, but it's also the smallest instance size. And for the performance tier, I'll also choose the smallest option, simply to save on costs. And with this setup, it comes out to about $19 per month for your database. When it comes to high availability, I will leave this as disabled. And for the backups, let's leave it with the default option, which is a 7-day retention period. Let me click save, and then let's continue with our database setup. When it comes to the availability zone, I will say no preference. We already said that we won't enable high availability. Now, when it comes to authentication, you can choose between Postgres and Microsoft Entra Authentication. I'm just going to use Postgres Authentication, and I need to provide an admin username, a password, and confirm the password. I'm going to input the username and password, but make sure to write these values down because we're going to need them to connect to our Postgres database. Now I'm going to move on to the next important step, which is networking. And here I'm going to be a bit loose with the requirements. I'm going to choose public access from the allowed IP addresses, and this also allows private endpoints. Now, private endpoints are what is meant to be used for connecting your Azure services to the Postgres instance, and public access can be used for allowing dedicated machines to connect to the Postgres database. Now, I'm going to use this to allow my IP address so that I can connect to my instance and apply my database migrations, and I won't be using the private endpoint for the Azure App Service, as this is a bit outside of the scope of this course. What I want to use is to allow public access from any Azure service. And this is also going to take care of the Azure App Service we're going to create in our next lesson, but I have to highlight that this isn't a best practice. So I'm going to tick this checkbox, and I'm also going to include my current IP address so that I can connect to this Postgres instance from my local machine. Then I'm going to click Next, and this is going to lead us to the Security tab. Here I'm going to leave the default options. We can skip over the tags and go into Review and Create and make sure that the correct values are present here. And once you confirm that and you're happy with everything, including the networking and the compute and storage setup, you can go ahead and create your Postgres flexible server. This will lead you to the deployment screen for your new resource, and it may take a couple of minutes for your database to be ready. While we are waiting for our Postgres instance to be set up in Azure, let's go ahead and discuss how we are currently applying database migrations and seeding any initial data. We're doing that when our ASP.NET Core application starts by automatically applying database migrations to our application schema and to our identity schema, which we use for storing user information. Now we're also seeding some initial data, which is just our two roles that are needed for ASP.NET Core identity. Now we will have to take care of both of these steps somehow for our application to be able to run in production. Now I won't be using this approach because I don't think it's the best option for applying your database migrations in production. So what we can do instead is generate some SQL scripts that we can apply to the database. Let me switch the startup project to DevHabit API, and I'll open up the package manager console. And here I can say script migration, specify my database context. Let's start with the application DB context, and I'm also going to pass in the idempotent flag. I'm going to execute this, and this is going to look at all of my migrations that I have for this database context and convert the migration definitions into a SQL script that I can execute on my database. So this is the SQL script that we get. It's going to create the DevHabit schema, the EF core migration history table, all of the tables and indexes that we need, and then we can apply this to our database. Now let's go ahead and do the same for the application identity DB context. I'll hit enter, and now this is going to create another SQL script, this time for the identity schema and all of the respective tables inside. So now we have to apply this to our production database. And if I go back to the Azure portal, my resource is now ready and I can navigate to the DevHabit database. From here, you can find your server name, which you can use to connect to your database instance. So let me go into dbeaver, and I'll go ahead and create a new database connection. I'll choose Postgres, and I'm going to paste in the value that I just got from the Azure portal. This is the host address of my Postgres instance. I'll be using the default port 5432. The default database name is Postgres. We can go ahead and change this if we want to. I'm going to leave it with the default value. Then I need to specify the username and password of the user that I created when setting up my Postgres instance, and I can go ahead and test the connection. And if everything is configured correctly, I'll be able to connect to this instance. So now I'll just go into the connection details, and I'll give my connection a name so that I can recognize it easily. And let's call this DevHabit Production. You can leave all the other values here as is, they don't really matter. And I'm going to finish this, and here is my new database connection. So you can see there's a Postgres database inside with the default schema, and it's empty. There are no tables inside. Now what I want to do is run a new SQL script here. We'll jump back into Visual Studio, and I'm going to copy the contents of the migration script that's going to create the DevHabit schema and all of the respective tables. Let's drop this script here, and let's execute everything. And you should see that this completes successfully and is going to create the required schema and tables. If I go ahead and refresh the schemas, I should be able to see the DevHabit schema with all of the tables inside. And here is my EF migration history table confirming that my migrations were applied correctly. So now I can close this down. Let's get rid of this migration script, and let's grab the one for the identity tables, and I'm going to paste it in here, execute everything. This also completes successfully, and if I refresh the schemas, here is my identity schema with the respective tables inside, and if I take a look at the EF migrations history, it contains my two database migrations. So now we can close this down. Our database is ready with all of the migrations applied, and in this example, I used SQL scripts for applying my migrations. The advantage of this approach is that it gives you the most control. You can review the exact SQL statements that are part of your database migrations and make sure that you don't do any destructive changes. You could also hand this off to your DBA, who can make sure that this is correct and then apply the respective migrations instead of you. An alternative could be using the CLI, where you have the update database command, and this is going to connect to your database. Granted, you will have to provide the correct connection string for this to happen, and this will do the same thing and apply your database migrations. Now, another option that you could consider is using migration bundles, and this is an excellent option when running in CI/CD pipelines. This is something that I will show you when we set up automated deployments. And now that our database server is ready, we can move on to our next lesson, where we are going to deploy the DevHabit REST API to Azure.